Ever wonder why an AI that can literally pass the bar exam or write a college-level essay completely falls apart when you ask it to fix a tiny bug in a Linux terminal? It's a pretty crazy paradox, right? Well, today, we're diving into an absolutely fascinating explainer on a research paper out of Princeton University. It introduces a system called SWE-agent, and we're going to see exactly how these researchers took AI from basically flailing blindly around a computer terminal to successfully solving complex, real-world software engineering issues. The secret? They built a completely new way for AI to interact with computers.
Here's a quick roadmap of how we're going to break this all down today. We'll start with the problem with AI coders, introduce the core idea of AI interfaces, walk through how SWE-agent actually works, see it in action, look at the hard results and limitations, and finish up with the future of automated software.
All right, let's kick things off with part one, the actual problem with AI coders.
So, we have to start by asking ourselves, why exactly do these incredibly smart AI models fail so miserably at basic coding tasks? You know, the disconnect isn't that they don't know how to code, they know the syntax, they understand the logic. The real issue is the environment we're forcing them to work in.
Think about how you or I code. We rely on a visual workspace, right? A graphical interface. If you make a typo, your editor usually throws a little red line under it to warn you. It's forgiving. But when we ask an AI to code, what do? We drop it into a text-only Linux shell. And honestly, it's a brutal, punishing environment for a language model. See, AI has a fixed context window, which is basically its short-term memory. If it runs a command and the computer spits back thousands of lines of useless text, its memory gets entirely wiped out. It literally forgets what it was doing. Plus, in a standard terminal, errors often just fail silently. The AI has absolutely no idea it messed up until the whole thing crashes.
Which brings us right into our second section, the core idea of AI interfaces.
This is where the researchers introduced a brilliant analogy. Human programmers use IDEs, integrated development environments like VS Code or PyCharm. We need those visual tools to organize our thoughts and work efficiently. Well, the paper argues that AI needs the exact same thing, but built natively for how an AI thinks. Enter the ACI, the Agent-Computer Interface.
So what is an ACI? Essentially, it's an abstraction layer sitting right between the AI agent and the computer. But instead of visual menus and buttons, it strips away all those distractions. It formats the computer's feedback into highly concise, text-based actions. It gives the AI specially designed commands that perfectly manage its memory limits, ensuring the model only sees exactly what it needs to see to solve the problem, nothing more, nothing less.
Let's move to section 3 and see how SWE-agent actually puts this into practice. We can break the whole SWE-agent process down into a very clean 3-step loop. Step 1. Search and navigate. The AI needs to find the specific file without getting flooded with data. Step 2. View and edit. Once it's there, it reads the code in safe, 100-line chunks and makes precise edits. And Step 3. Feedback and linting. The environment immediately checks the code for syntax errors and instantly feeds that context right back to the agent.
When you look at the architecture, it's basically an ongoing conversation. The language model agent sends out simple AI-friendly commands, stuff like search or edit. The ACI processes that action, guards against massive data dumps, and returns clean, structured feedback. The AI thinks, acts, gets feedback, adjusts its plan, and acts again. It's entirely self-directed, but safely kept within the guardrails of the ACI.
Okay, section 4. Let's see SWE-agent in action and look at some real-world examples.
Let's compare the old way versus the new way across 3 common scenarios. First up, finding a bug. A traditional AI tries to use the grep command, gets dumped with thousands of lines, and completely overloads. But the ACI provides a custom search file command that restricts the output to just 50 concise hits. The AI's memory stays perfectly intact. Second scenario, editing code. Normally, an AI in a terminal tries to overwrite a whole file just to change one word. It's a total disaster waiting to happen. The ACI instead provides a targeted edit command that only swaps out specific line numbers. And third, syntax errors. Remember those silent failures we talked about? The ACI has a built-in linter. It catches the typo instantly, explains the error to the AI, and the AI just autocorrects it on the spot.
Just look at how this custom ACI file viewer handles code. It intentionally only displays 100 lines at a time. It explicitly tells the AI how many lines are hidden above and below the current view, and it attaches a line number to every single line of code. This is absolutely crucial. It creates a map, protecting the AI from getting completely lost inside massive, sprawling codebases.
And when the agent actually goes to fix the bug, it uses that precision. Here you can see the agent issuing a command to edit specifically lines 404 through 407. It just surgically swaps those exact lines. No more asking an AI to blindly rewrite a 3,000-line Python file from scratch just to add a missing comma.
Moving on to Section 5, the hard results and, of course, the limitations. 12.47%. Now, out of context, you might be thinking, hey, a 12% pass rate sounds pretty low. But you have to realize what test we're talking about here. SWE-bench is a grueling data set of thousands of incredibly complex Python bugs pulled straight from real, high-level GitHub repositories. These are gnarly issues that take human engineers hours or days to solve.
To really put that into perspective, look at the previous state of the art. The best baseline out there was only solving 3.8% of these bugs by simply building the right interface. Literally, without even upgrading the underlying AI model, SWE-agent more than tripled the success rate to 12.47%. That is huge. It proves the bottleneck wasn't the AI's brain, it was the terrible tools we were forcing it to use.
But let's be objective here. The system is definitely not perfect. Looking at the failure modes, 52% of the time it fails, it's because it writes an incorrect or overly specific fix, meaning it navigated perfectly, found the bug, and edited the file, but its logic was just wrong. Another 23% of the time, it gets caught in a loop of cascading failed edits, basically trying to fix a mistake and making it worse. But honestly, this is actually a great sign. It means the interface works so well that the AI is finally failing at the logic of software engineering, rather than just fumbling with the computer terminal.
And finally, Section 6, what this all means for the future of automated software.
There's a quote from the paper that I think perfectly captures the biggest takeaway from this whole lesson. The researchers say that language model agents are essentially a new category of end users. They have their own needs, their own superpowers, and their own strict limitations. If we want AI to do complex digital labor, we have to stop pretending they are human programmers. We have to design specifically for them.
Which leaves us with a pretty wild thought to chew on. SWE-agent is really just the very first IDE built natively for an AI. So as these AI agents get faster, smarter, and get access to better custom tools, what is human-AI collaboration going to look like tomorrow? Are we going to stop writing code ourselves and just transition to managing these agent-computer interfaces? It's a massive paradigm shift happening right in front of us, and definitely a space you're going to want to keep a close eye on.